Our last video showed us how to do some of the basics of taking a limit. So now that we've done that, let's try some little more complicated examples. Here I have the limit as x approaches 3 of x squared minus 5x plus 6 all over x squared minus 2x minus 3. Well, in our last video we talked about how we can just evaluate the top at 3 and evaluate the bottom at 3. However, we run into an issue. If I stick in 3 into the top, I just get a 0, and if I stick in a 3 on the bottom, I just get a 0. So I get 0 over 0. And this is known as an indeterminate form because it can mean a lot of different things. What 0 divided by 0 means is 0 times what is 0? Well, anything. 0 times anything is 0. So this could literally be anything. So let's try to think of other ways that we might be able to evaluate this. Our first default, since we see these quadratics, would probably be to factor. So let's try to factor. We have the limit as x approaches 3. On the top, two numbers that multiply to be 6 and add to be negative 5 would be negative 2 and negative 3. On the bottom, two numbers that multiply to be negative 3 and add to be negative 2 would be 1 and negative 3. And now I can see this x minus 3 term cancel. So now I just have the limit as x approaches 3 of x minus 2 over x plus 1. Now when I actually evaluate at 3, I have 3 minus 2 and 3 plus 1, so I get my answer of 1/4. So if you do get a 0 over 0, this is one strategy to start with, is try to factor and see if things cancel nicely. Here we have the limit as x approaches 5 of x minus 5 over the square root of x plus 4 minus 3. Once again, if you stick in 5, you get 0 over 0. So we have an indeterminate form. We need to use another method. In our last example, we were just able to do some basic factoring. However, that's not going to work here. We don't have any x squareds and we have the square root. So instead, we're going to default to another algebra method and rationalize the denominator. Just as a reminder, when we rationalize the denominator, we're going to multiply both the top and the bottom by the conjugate of the denominator, which just means change the sign in the middle. So I'm going to multiply both the top and the bottom by the square root of x plus 4 minus 3. When I do this, on the top, I'm just going to leave it as x minus 5 times the square root of x plus 4 plus 3. I don't want to actually multiply that out. However, on the bottom I am, because whenever we have a plus b times a minus b, we just square the first minus square the second. A squared minus b squared. So I'm going to square the first thing. Square root of x plus 4 squared is x plus 4 minus 3 squared, which is 9. Which you'll notice that x plus 4 minus 9 is just x minus 5. So we have things cancel again. I now have the limit as x approaches 5 of the square root of x plus 4 plus 3. 5 plus 4 is 9, and the square root of 9 is 3. So we have 3 plus 3, which is 6. So now we have two methods that we can try whenever we have this 0 over 0 form. We could factor, or we could try to rationalize the denominator. Now let's look at this one. The limit as x approaches 0 of x cubed plus 2x over x cubed. Well, we still get a 0 over 0. There's nothing to rationalize, so rationalizing the denominator won't help, and we can't really factor. However, we can use a different method, which is called splitting the fraction. I'm going to rewrite this as the limit as x approaches 0 of x cubed over x cubed plus 2x over x cubed. Now, as I try to simplify this, x cubed over x cubed is 1. And here I can cancel one of the x's and get 2 over x squared. Well, the limit as x approaches 0 of 1 is just 1. But what about this other thing? This is now 2 over 0. It's no longer 0 over 0, so we're making progress. but what exactly is it? And so the thing is, we're going to have to think about this a little more. Let's think about exactly what the limit as x approaches 0 means. It means we need to stick in numbers that are really close to 0, like 0.00001 or negative 0.00001. And as we stick in these numbers that are closer and closer and closer to 0, when we square them, they're going to get even smaller. And then when we put them on the bottom of a fraction, it's going to make this number even bigger. And this is actually tending towards infinity. The best way to do this might be to make this table where we think of numbers for x and figure out exactly what 2x squared is. Let's think of 0.1, 0.01, 0.001, 0.0001, and I'll let you fill in the other side. And you'll notice that the smaller we get x, the bigger 2 over x squared is going to be. So we get this infinite thing.